Alright folks, we've made it to our last lesson in chapter 3, which is the random object, which belongs of course to the random number generator. And for those of you who are gamers, might be familiar with RNG. So RNG, or the random number generator, right? How many times have you played a game and something's been left to chance? How many times have you been trying, for example, to get a piece of loot but have to pray to the RNGs? This is an example, of course, of the random number generator. Other examples that could include things like dice rolls, a random card being drawn from a deck, etc. Although we are using the term random here, Java actually uses pseudo-random numbers. This means that although the numbers appear to be random, the sequence is actually initialized by a seed value. If the seed value is to initialize the random number generator, then the exact sequence will be generated. So let's take a look at the random object. Java includes a random object that can generate different types of random numbers. In this section, we will generate random numbers using what's called a uniform distribution model, meaning every number has a likely chance to occur. However, random does support other distributions. If we want to use a random object, we simply import the class, import java.util.random. To create a random object, we add the code random number generator equals new random. If we want to store the random value, so let's say we want to generate a random integer, we can use int_r equals random generator.nextInt. If I want to specify that I want that random integer to go from 0 to n-1, I just use int_r equals random generator.nextInt n. So if I wanted, let's say, that to be I want the numbers to go from 0 to 3, n would then be 4, because it's always going to be 1 less than whatever number I'm looking at, or 1 more than. To generate a random integer in a different range, we can offset by adding the offset. So here, I want 4, 5, or 6, so I have int_r equals random generator.nextInt 3 plus 4. Remember, 3 in there would give me the choices of 0, 1, or 2. But then all those numbers are getting added 4 to it. So instead of 0, 1, 2, I get 4, 5, 6. And of course, if I wanted to do a double, I can use just double r equals random generator.nextDouble. Right? And all the other things that you've seen would apply here as well. Here's a quick sample code using a coin flip. So you can see we have a random generator and equals new random, int counter equals 1. While counter is less than 5, I'm going to have it go ahead and do this coin flip thing to determine if it's heads or tails. If it is 1 with that random generation, then I know I have a heads. Otherwise, I want it to print out tails. And here would be the output. So here's my 5 flips, and I got tails, 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 and then head. Alright, let's talk quickly about math.random. Java also has a method to generate random doubles without requiring the user to create a random object. As we commonly desire an int, we often have to do a typecast here because this is a double object. So int num equals parentheses int, that's the typecasting, math.random times 6 plus 1. This example generates a random number between 1 and 6. Right? And this is because math.random will only generate a number between 0.0 and 1.0. By multiplying by 6 and adding 1, we are changing the range from 0.0 to 1.0 to 1 to 6. Multiplying by 6 increases it by a factor of 6, and then the addition will be a shift of how much ever we want it to be. And here's your self-test questions. Number 1. What numbers could be generated by random generator.nextInt 5 plus 10, where random generator is an object of random? Number 2. What range of numbers could be generated by random generator.nextDouble times 3 plus 1, where random generator is an object of random? Number 3. Use the method math.random to generate a random double that is greater than or equal to 10, but less than 20. And that wraps up our lesson, folks. Until next time.